Hello everybody, this is the notes for week 5. Just a real quick rundown. We did a bunch of these problems, so this is really should be review. But we're talking about increasing and decreasing intervals for a function. So basically, where is the graph going up? For which x values? For which x values is the graph going down? Simple idea. But what we are looking for is a thing called critical numbers. To find those, we have to find the derivative, set the derivative equal to 0, and any x values where the derivative is undefined. So that's where we start with our derivative, f prime of x. Alright, so basically just power rule here, multiplied by 3, we get 2x squared, times by 2, we get plus 1x, minus 10. Alright, we set our derivatives, I got a little ahead of myself. There are no x values that make this derivative undefined, so our critical numbers are coming from where the derivative is equal to 0. Alright, so different powers of x. We got to do some factoring. So I like to do FOIL in reverse. 2x times x gets us our 2x squared for our first terms. The last two terms have to multiply to give us a negative 10. I like plus 5 and minus 2. And the reason I like that is the outside and inside part of FOIL. Inside 5x, outside is a minus 4x. When you combine those like terms, there's our middle term of positive 1x. Alright, set each of our factors equal to 0. That's an easy one to solve here. X equals 2. That's one of our critical numbers. X equals a negative 5/2. It's another one of our critical numbers. Okay, so what we do is we take those critical numbers, we put them onto a number line in order. Negative 5/2, positive 2. And then what we're going to do is test some numbers. What we are looking for is the derivative. Up here, we are looking for the derivative to be positive, greater than 0. That tells us the function is going to be increasing. If that derivative is negative, less than 0, that tells us the function is going to be decreasing. Okay, that's the gist of this section. So we pick our test numbers, less than negative 5/2. So less than negative 2.5, I'm going negative 3. In between our two critical numbers, I'm going to go 0. More than 2, I'm going positive 3. We plug those things into our derivative, f prime of, again, our test numbers, not our critical numbers, but our test numbers. F double prime of 0, or sorry, not double prime, f prime of 3. Okay, so we are looking for our derivative to be positive or negative. Okay, there is a quick way. We can do this testing. That's not a big deal. Sometimes it's easy and quick. Other times, we can look at our derivative function. It is a quadratic. Because it's a positive x squared, we know our parabola is opening up. That's our derivative. So we know where that derivative is equal to, that quadratic is equal to 0. Pretend that's a nice smooth parabola, even though it doesn't look, it looks awful basically. But when that derivative is above the x-axis, like it is for this interval, it's positive. Again, we don't care what the number is, we just care if it's positive or negative. In between our two critical numbers, our derivative is below the x-axis, so it is negative. Above the x-axis, positive. Okay, so our answer, our function is increasing on the intervals where the derivative was positive. So that was this interval, less than negative 5/2. So I'm going to write it as negative infinity up to negative 5/2. Our derivative was also positive for this test number of 3. That was this interval, more than 2. So I'm going to go from 2 to positive infinity. Our function was decreasing where the derivative was negative. That was for our test value of 0. That was in between our critical numbers. So from negative x values, from negative 5/2 up to 2. And that's our answer. That's how we do this section, finding the intervals of increasing, decreasing. Some of the functions that you'll see in the assignment will be a little bit tougher than this, but that's the gist. Hope everybody's doing well. Take care. Let me know if you got questions.